Okay, we're going to talk about simplifying expressions, and the first thing we're going to talk about are how to determine whether or not two expressions are equivalent. All right. Now, first of all, what I want to do is I want to see whether or not these first two, 3n minus 4 and 3 times n minus 4 and 3n minus 12, I want to know if they are both equivalent. Well, one of the first things I have to do is distribute this. And remember, when you distribute, you're multiplying. So 3 times n is 3n, and then 3 times negative 4 is minus 12. Now, if you notice, this is the same as that. So yes, they are equivalent. All right? Now, the next one we're going to do is we're going to look at 3n minus 2. Again, we're going to distribute 3n, and then 3 times negative 2 is negative 6, and as you can tell, these are both equivalent. Now, the last one, 3n plus 4. Well, remember, we have that property where we can flip it around, 4 plus 3n. Same thing, the 4 is positive in both the cases, and the 3n is positive, and they're both the same. So those as well are equivalent. Okay, so now I'm going to give you time to write this down. Make sure these are in your notes. These are, again, for equivalent expressions. This is determining whether or not two expressions are equivalent or are the same. So I'll give you a second to copy those down. Okay, so the next thing we're going to do is we're going to look at combining like terms. Now, what makes terms the same? Well, again, on this category right here, we're going to look at like terms, and then in this category here, we're going to look at unlike terms. All right? Now, let's take a look at like terms first. Notice that each one of these has an x involved. So these are all like terms. The next category, these all right here are numbers. They're constants. So they are all like terms. And then the final row, 3y, 19y, and y all have y's in common. Now, the next thing we're going to look at is we're going to look at the unlike terms and what makes things unlike. Well, in this case, notice that this has a 2x, whereas this has an x squared. Not the same. And this has an x times y, which is not the same as x squared, nor is it the same as 2x. The next category we're going to look at is, our next row is 1x, 3, and 100. Notice they all have a number. Notice they all have a number, but they don't have the same variable. This one has a y for variable. This has no variable, and this has a y. I'm sorry, this has an x. This right here has an x for a variable. This has a y for a variable. They don't have the same variable, therefore they are unlike terms. And then finally, in this last row, I have 7a, 5b, and 2. Well, a is not the same as b, therefore these are not like terms. They all have numbers, but again, these first two have variables attached to them, which are not the same. Okay, this next section, we're going to talk about the distributive property. Now remember, the distributive property is like you pass things out to everything or everyone in the parentheses. For instance, notice I have 2 times x plus 3. That means I have two groups of x plus 3. Now this is one way of doing it. I have an x and an x, which is 2x. 3 plus 3 is plus 6. Now that's one method of doing this. However, what I want to cover is I want to show you how to use the distributive property to do the same thing. Now, in this case, we're going to distribute. This is 2 times x plus 3. So 2 times x is 2x. 2 times plus 3 is plus 6. And that would be our final expression. This next one down here is a little bit more complex. Notice we have 3 times x plus 1, and then we have a negative 4 times x minus 2. We're going to take our time and we're going to do the first set of parentheses first. Now in this first one, I have 3 times x, which is 3x. And then 3 times plus 1. Remember, you have to distribute to everything within the parentheses. So 3 times 1 is plus 3. Now this next one, you've got to know, or you've got to be aware that this is a negative 4 or minus 4. So we're gonna distribute right here, not just the 4, but you got to distribute that negative as well. Okay. Now, let me erase that. There we go. So here we go. What we're going to do is we're going to negative 4 times x is a minus 4x. Now, once I use that negative 4, I have to use it again. You don't just use it the negative one time and it's done. Negative 4 times negative 2 is the same as negative 4 times negative 2. Now remember, negative times a negative is a positive, and 4 times 2 is 8. Once we have this established, now we can combine like terms. Well, in this case, I have a 3x and a minus 4x. Well, that leaves me with a negative 1x. And then I have a plus 3 and a plus 8, which is plus 11. Therefore, my final expression is negative x plus 11, or I can have it as 11 minus x. Either way would work. I prefer neither way. Both are the same, so either expression would work.
How's it going?
Okay, now on this next problem, we're going to step it up a notch. Now don't be afraid that it's a decimal or a fraction. Just go through your same process. And in this process, we have 3.5p plus 2.5p times 1 minus p. Now remember, you cannot combine these two. You can't, because you have a multiplication problem right here. Alright, so before we do anything, let's go ahead and get that situated. I'm going to go ahead and erase this right quick. Alright, and then we're going to begin our problem. Alright, here we go. Now, in this case right here, what I want to do is I'm going to distribute this first. So I'm going to write down my 3.5p because I'm not doing anything with it yet. Now the first thing I'm going to do is 2.5p times 1. Well, that's just going to be plus 2.5p. Now this next one is 2.5p times negative p. Well, remember, there's an understood 1 right there. So 2.5 times 1 times negative 1 is negative 2.5. Now remember, in this case, p times p is p to the second power, because there's that rule where you add the exponents. Now, let's go ahead and combine like terms. If you notice, I like to circle the like terms. So these two are the same. 3.5p plus 2.5p. Well, if I have 350 and 250, that means I'm going to have 6. So 6p, not p squared, but 6p. Now, I'm just going to bring this down as a minus 2.5p squared. Now notice, this p right here and this p squared are not like terms, so you cannot combine them. So do not subtract 6 minus 2.5. Just leave it like that, and that is your answer.